Examples. These are examples of using logs to solve. Example 1 is quite simply just using a calculator to solve some logs. So log 3 of 6,561 into our calculator and we get out 8. So in our calculator, the process that we're actually doing is we are using control and then the 10 to the power of x button. So control log. Then you fill in the base number, as in this particular case 5, and then what you are logging. So this massive number 152587890625, and you get out a result of 16. So I'm going through fairly quickly. You can pause and slow this down if you wish, but there are a number of different techniques for doing this. So there is this pressing the control and then this button here to get up the log where you fill in the brackets. Another method which was used just before is pressing this up button twice. So when you press up, it actually takes the last line and highlights it. And if you press up again, it'll take this part of the line and highlight it. Once this is highlighted, you can press enter and actually just change the 2 and the 512 to whatever it happens to be that you're after. Now, in this particular example, I'm up to log 9 of negative 59,049. When I try to solve this, it actually pops up with an error. So I put it in and I get up this domain error. So it's actually telling us that even though this looks like it should be possible, it's actually not. So we'd say that there's no solution to this problem. Now, the next question is referring to this. So what happened? No solution. So if we tried this with something like log 10 of negative 100,000, what would we get? Or would we get something? And the answer to that is no. You can try it if you want. Use a calculator, put in log 10 of negative 100,000 and see what happens. You should get up an error that looks basically exactly the same as this. Now the question, why not? It's a simple fact is that you can't log a negative number. So as long as this value in here is negative, it's always going to pop up with an error. So we can't log a negative number. The following example after this, example 3, the last part, 3F, we'll actually try to make our way around this problem. But if you're given it in this format of log something of a negative number, we would say no solution. There is no solution to this. So why not? It's negative, and it must be positive for a log to be able to work. So these examples here are actually just taking the original question, 5 to the power of x equal to something, 78,125, and we want to know what x is. Now you could use guess and check. Chuck into your calculator 5 to the power of 2, 25. 5 to the power of 3, 125. 5 to the power of 4, 525, I think off the top of my head. Either way, what you're going to find is that it will get bigger very quick. Guess and check takes a while. So instead of using guess and check, we use logs. Now this goes back to the very first principles, where if you log both sides by log base 5, the log base 5 of 5 will cancel out, leaving the x, which means that this side of the equation will just be log base 5 of 78,125. This is something we can put into the calculator and we'll get out the result of 7. So x in this particular case is 7. If in the past you haven't been boxing your answers will always need to be boxed, please. So red box your end answer and only your end answer. So this question says solve the following for x, hence I would red box x equals a number. Next question. 2 to the power of x equals 32. Again, rewriting that as log base 2 of 32, use the calculator, get out the result of x equals 5. If we use something like decimals, 0.2 to the power of x is equal to 0.0000 0.013 into our calculator, it is actually going to give us an approximate answer. So I'm going to get rid of my equal sign here and put in an approximately equal to, and I'm rounding to 2 decimal places. If you actually put into your calculator 0.2 to the power of 7, you will get out 0.0000013. So it's a pretty close approximation. Part D is fractions. So fractions will work exactly the same way as a normal equation. So chuck it in as a base of 1/3 where you're logging 1 on 177,147 and you get out a result of 11. Really big numbers still work. Just chuck it in and we get out a result of, if we keep going, result of 15, I apologize. Now, here's an interesting one. When we rearrange this, we get out that there's no possible solution, okay? So if we look at this, we rearrange it without taking anything into consideration, we get x equals log -5 of -125. By a prior example, we know that when we log a negative number, we have no solution. But this is without taking into account that the question didn't ask this, the question asked this, what is x? If we got rid of both of those negatives, we said this 5 to the power of x is equal to 125, how would we solve it? We'd go log base 5 of 125, and we'd put that into our calculator to get a result of 3. Now, I'm going to suggest that x equals 3 is correct, but let's check this. If we go -5 to the power of 3, it does equal -125, so this is accurate. So although using logs with the original calculation doesn't work, we can, however, manipulate it to get a solution. This will not always work, so always check your answer, please. This is the basic logs. We will look at log laws in a further tutorial.